Hi there, welcome back to Haguin School. Let's talk about bitmap image. So first of all, what is a bitmap image? A bitmap image is a rectangular grid built from a number of pixels, which is the smallest identifier component of an image. And next, each pixel is a single square of one color, and each pixel's color will be stored as a binary number. So if you look at this penguin here, look at all this square here. So all this little square here is called as a pixel here, and each pixel will have its own color here. And then we have bit depth here, which is the number of bits used to represent each color. The higher the bit depth, the higher the file size. And next will be color depth here, which is the number of possible colors that can be used. So the higher the color depth, the higher the file size. Basically, bit depth means how many bits used to represent the color, and color depth means how many colors we can use to represent the image. And then each bitmap image will contain file header, which stores data about the image such as file format, number of bits per pixel, and then file size. And next, the clarity of bitmap image view on the screen will depend on two factors. The first factor will be image resolution. So what is image resolution? It's the number of pixel wide horizontal, so this horizontal pixel here, by the number of pixel high vertical. So this vertical pixel here, then make up an image. The higher the image resolution, the sharper the image. And next will be screen resolution. So it will be the number of pixel wide horizontal by the number of pixel high that make up a screen display. So basically, how clear an image is depend on two factors, which is this image resolution and also the screen resolution. Next will be type of encoding for bitmaps. So for this syllabus, we have four main types of encoding. Let's look at the first encoding. It will be monochrome here, and the bit depth will be 1 bit, and the color depth will be 2, which means bit depth is either 0 or 1 since 1 bit here. Therefore, only two colors, black and white. And take note that 1 byte stores 8 pixels, since 1 pixel is equal to 1 bit based on this monochrome here. And the next one will be 16 color here, so we will use 4 bits to represent 16 colors here, since we have 0, 0, 0, 0 all the way to 1, 1, 1, 1. So 16 possible colors here. Therefore, the color depth will be 16 here. And then take note that 1 byte will store 2 pixels, since each pixel here will be 4 bits here. And then next will be 256 color will be 8 bits here, which is exactly 1 byte here. And the color depth will be 256 colors here. Therefore, 1 byte stores 1 pixel here. And finally will be 24-bit color here. So 24 bits is equal to 3 bytes here. And the number of possible color will be 2 to the power of 24, which is this 16 millions here. So it will be millions of different colors are possible for this type of encoding here. Now let's look at a typical exam question for bitmap image. So it will be estimate the file size for a bitmap image. So this is a very popular question for the paper 1 exam. And now let's look at the question here. First of all, an image is scanned with an image resolution of 1024 times 512 pixels and a color depth of 8 bits per pixel. So this is the 256 color encoding here. And next will be calculate an estimate for the file size, giving your answer in mebibytes, show your working. So we have to give the answer in mebibytes here. So how do you do this? It's pretty simple here. First of all, total file size equal to 1024 times 512 times 8 bits, since 1 pixel is equal to 8 bits here. We are calculating this in terms of bit first. And next will be 1 mebibytes equal to 1 times 8. So why 8? Because 1 byte is equal to 8 bits here times 1024 times 1024 here. And then we just have to divide this by this here. Therefore, actual file size is equal to 1024 times 512 times 8 divided by 1 times 8 times 1024 times 1024 here. So for this exam, you are not supposed to use calculator, so don't bother to do like 1024 times 512. We can just do some crossing out here. So first of all, 1024 will cross out with this 1024 here. And then 512 will cross out with this 1024 here, resulting in 1 and 2 here. And then 8 cross out with this 8 here, resulting in 1 and 1 here. Therefore, we will get 1 times 1 times 1 divided by 1 times 1 times 1 times 2, which is actually equal to 1 over 2 here. Therefore, the final solution will be 0.5 mebibytes for this question here. The next question will be action versus file size. So the question is, the bitmap image on the right has a resolution of 4096 times 4096 pixels and a color depth of 24 bits per pixel. And next, the image is displayed on a monitor that has a screen resolution of 1920 times 1080 pixel here. So basically, we are displaying this image on a screen with this resolution here. And the question is, tick one box in each row to identify the effect of each action on the image file size. Now let's look at this table here. So first of all, these are the action, whether it increase, decrease, or no change to the file size. So the action will be change the color depth of the image file to 16 bits per pixel. So the original bits per pixel will be 24 bits per pixel. Now we reduce number of bits per pixel, which means it will decrease the file size here. And next will be change the screen resolution to 1366 times 768 pixel here. So for this one here, we are just changing this screen resolution here. We are not touching the image here. Therefore, the solution will be no change to the file size. And the last action will be change the color of the rectangle from black to red here. We are just changing this color from black to red. We are not changing the color depth. We are not changing the pixel here. Therefore, the solution will be no change to the file size here. And this last question is for you here. Estimate the file size for a bitmap image. And the question will be, a bitmap image has a resolution of 1000 pixel wide by 2000 pixel high. The color depth is 16 bits. Calculate an estimate of the file size in megabytes here. So the solution has to be in megabytes here. And next, show your working and the file size is equal to what? Megabytes here. So feel free to refer back to my previous example and see if you can solve this question here. Once you are done, you can write down your working and solution in the comment section below. Thank you, and I'll see you again then. Bye bye.